day, everyone. You are watching God Science, and let me first introduce ourselves so that you know who we are and our motives for these videos. And let's get started. My name is Tracy King Bulan. Hi, Mark.
Hi, I'm Godfrey. I'm Christian. And I'm Denver.
And I'm Angelo.
Hey, do you know the Big Bang? No, bro. I can't answer your question. Why don't we ask other people? So that's a great idea. You go to the left and go to the right. Okay. Hey, do you know the Big Bang?
For me, the Big Bang is about the galaxy and that's expanding like the universe, the other planets and stars that combine and make another star.
Bro, did you get the answers you were looking for? I'm not satisfied, bro. I need more answer about the Big Bang. Okay? Hey, who are you?
Did you see the answers to all your questions?
Who are you?
Okay, so can give you all the answers that you want, but except for what my name is.
Okay. So, you can answer our question. What is the Big Bang or creation?
The beginning of everything, the Big Bang. The idea that the universe was suddenly born and is not infinite. Up to the middle of the 20th century, most scientists thought of the universe as infinite and ageless. Until Einstein's theory of relativity gave us a better understanding of gravity, and Edwin Hubble discovered that galaxies are moving apart from one another in a way that fits previous predictions. In 1964, by accident, cosmic background radiation was discovered, a relic of the early universe, which together with other observational evidence made the Big Bang the accepted theory in science. Since then, improved technology like the Hubble telescope has given us a pretty good picture of the Big Bang and the structure of the cosmos. Recent observations even seem to suggest that the expansion of the universe is accelerating. But how did this Big Bang work? How can something come from nothing? Let's explore what we know. We can ignore the beginning part for now. First of all, the Big Bang was not an explosion. It was all space, stretching everywhere, all at once. The universe started very, very, very small and quickly expanded to the size of a football. The universe didn't expand into anything, space was just expanding into itself. The universe cannot expand into anything because the universe has no borders. There is, by definition, no outside the universe. The universe is all there is. In this hot, dense environment, energy manifested itself in particles that existed only for the tiniest glimpses of time. From gluons, pairs of quarks were created, which destroyed one another, perhaps after giving off more gluons. These found other short-lived quarks to interact with, forming new quark pairs and gluons again. Matter and energy were not just theoretically equivalent, it was so hot they were practically the same stuff. Somewhere around this time, matter won over antimatter. Today, we're left with almost all matter and nearly no antimatter at all. Somehow, 1,000,000,001 matter particles were formed for every 1,000,000,000 particles of antimatter. Instead of one massive ultimate force in the universe, there were now several refined versions of it acting under different rules. By now, the universe has stretched to 1 billion kilometers in diameter, which leads to a decrease in temperature. The cycle of quarks being born and converted back to energy suddenly stops. From now on, we work with what we have. Quarks begin forming new particles, hadrons, like protons and neutrons. There are many, many combinations of quarks that can form all sorts of hadrons, but only very few are reasonably stable for any length of time. Please take a moment to appreciate that by now, only 1 second has passed since the beginning of everything. The universe, which has grown to 100 billion kilometers, is now cold enough to allow most of the neutrons to decay into protons and form the first atom, hydrogen. Imagine the universe at this point as an extremely hot soup, 10 billion degrees Celsius, filled with countless particles and energy. Over the next few minutes, things cooled and settled down very fast. Atoms formed out of hadrons and electrons, making for a stable and electrically neutral environment. Some call this period the Dark Age because there were no stars and the hydrogen gas didn't allow visible light to move around. But what's the meaning of visible light anyway, when there's nothing alive yet that could have eyes? When the hydrogen gas clumped together after millions of years and gravity put it under great pressure, stars and galaxies began to form. Their radiation dissolved the stable hydrogen gas into a plasma that still permeates the universe today and allows visible light to pass. Finally, there was light. Okay, but what about the part we didn't talk about? What happened right at the beginning? This part can be defined as the Big Bang. We don't know at all what happened here. At this point, our tools break down. Natural laws stop making sense. Time itself becomes wibbly-wobbly. To understand what happened here, we need a theory that unifies Einstein's relativity and quantum mechanics, something countless scientists are working on right now. But this leaves us with lots of unanswered questions. Were there universes before our own? Is this the first and only universe? What started the Big Bang, or did it just occur naturally based on laws we don't understand yet? We don't know, and maybe we never will. But what we do know is that the universe as we know it started here and gave birth to particles, galaxies, stars, the Earth, and you. Since we ourselves are made of dead stars, we are not separate from the universe. We are part of it. You could even say that we are the universe's way of experiencing itself. So let's keep on experiencing it until there are no more questions to ask.
Do you want to see the creation of your own planet?
Yes, so that we and the viewers will know the beginning.
The formation of the Earth is related to the formation of the solar system. The gases that formed the solar system gradually started shrinking. Increasingly more matter gathered in the center, while temperature was constantly increasing. The Sun formed from this condensed molecular cloud of dust. Due to rapid rotation, the rest of the cloud scattered and flattened into an orbiting protoplanetary disk around the Sun. The particles of dust in the protoplanetary disk stuck together electrostatically, and when these clumps of dust reached kilometers in size, they began to collapse under their own gravity, forming protoplanets. This is also how the Earth formed 4.6 billion years ago. Around 170 million years after the formation of the Earth, a similarly young planet, known as Theia, struck the Earth's still soft crust. Theia was demolished after the collision, and it merged with the Earth. The Earth's mass therefore increased, effectively reaching its current mass. The impact created a large ring of debris around the Earth, which later formed into the Moon. After the dissolution of the ring, the Moon became a glowing hot celestial body orbiting 25,000 kilometers above the Earth. During this period, the Moon still had volcanoes, lava flows, and its own magnetic field. The tidal phenomenon that occurs between the Earth and the Moon led to various changes. Firstly, the Moon became tidally locked with the Earth, meaning it takes the Moon just as long to rotate around its own axis as it does to revolve around the Earth. Secondly, the Moon gradually receded from the Earth, cooled down, and then became geologically inactive. Currently, the average distance of the Moon from the Earth is 384,000 kilometers. Even to this day, it is receding from the Earth, 3.8 centimeters a year. As a result, it takes the Moon increasingly more time to revolve around the Earth. However, due to tidal locking, the period it takes to rotate around its own axis is also increasing. The tidal phenomenon also affects the Earth, The Earth's rotation period is decreasing, meaning the length of the Earth's day is slowly increasing.
Okay.
Oh, hello there. Come with us and we'll show you around this place.
What's that, brother?
This garden is where we get our food and water every day.
Yeah, the fruits and vegetable here is our source of energy and it gives nutrients in our body.
Yeah, and the sun gives us vitamin C. Wow, that's wonderful. So easy to see. So we've seen your place already. Why don't you come to our place? Oh, that's a great idea. Come with us?
Yes, sure.
Don't make us worry about you guys, okay?
We made some friends along our way.
I'm glad to see you both of you guys safe. Me and your mother are worried about you. So what's the name of your friends?
This Adam and Eva.
Nice to meet you, Mr. and Mrs. Anna.
Nice to meet you too.
Come inside. Welcome to our house. Thank you, Mr. and Mrs. Anna, for the warm welcome. We appreciate it.
And you're coming to the house of the jazz.
Oh, you guys are back. So how's the tour around the place? I'll make some drinks for all of you.
Now we'll cook food for us, okay? Just wait here.
Your place is so good, Mrs. Anna. It's really nice.
Come together with us. So today we'll create a food named scrambled egg.
That's right.
So here are our ingredients: egg.
Oh, we have it in our garden.
Oh really? That's nice. Oh, the eggs already cooked.
Are you the friends of Noah and Lee?
Yes.
Who are you?
I'm Mr. Joaquin. I am their tutor. Do you want to know the states of matter?
Yes, we would like to.
Okay, let's start. The parts of state of matter is solid, liquid, gas, and plasma. So the plasma is, we will not discuss about that because it's beyond our examples. So let's go. Do you see that boiling hot water in the pot? The boiling water is the liquid part. After a minute, this will happen. The part of water will become evaporated and it will become gas. So it's called evaporation.
Amazing. Tell us more.
Okay, here's your cold drink. I wish you like it.
Wow, that's amazing.
So, for the next example is this ice drink you're drinking. The ice represents a solid, and after a minute, it will turn into a liquid, like this water. So, it's called melting process. Right? And the other process is liquid turning into solid, and that is freezing process, which this drinking water will turn into ice.
Thank you for watching our video, God Science, and I hope you learned something new about our topics. And finally, this is my final goodbye. And once again, my name is Curtis King H. Buhula. This is my teammate.
I'm Ira May Cortado.
I'm Angelo Joaquin.
Hi, I'm Gatsby. I'm Denver Guitar. I'm Christian.
Hi, I'm Mark.
I'm Carla, and we are the group.
And this is God Science. See you in the next adventures.
From the top, 1, 2, 3, go.
What are the name of your friends?
And this is Evan.
Thank you for watching our
Do you want to see the creation of your planets?
Yes. So that we and the viewers will know about the universe.
Do you see that boiling hot water in the pot?
Here lang ako.
Amazing.
Ano na, Bistan?
Naglakad na lang po. So what the name of your friends?
This Adam and Eva.
Are you Taylor?
Welcome to ulit. Okay, 1, 2, 3. 1, 2, 3, go. Oh, the scrambled egg. Already booked.
Scrambles eggs.
The egg na lang. 1, 2, 3, go.
Tutor.
Oh, the scrambled. 1, 2, 3, go.